Welcome once again in the class of water engineering. So we are learning hydrology. I am Mr. Sisogule, Assistant Professor, Civil Engineering Department. We'll see the runoff calculation in this lecture. So runoff is defined as a portion of the precipitation that makes its way towards the rivers or oceans as surface or subsurface flow. As here you can see in this diagram, this thing we have discussed earlier also. So this is called as a interflow and this is the base flow. This is overland flow. So this is the nothing but the portion of precipitation that makes its way towards the rivers by this overland flow or interflow. Now the classification of runoff according to the source, as I told you earlier, the surface runoff that includes all overland flow as well as the precipitation falling directly onto the stream channels. Overland flow, it is a portion of a runoff that travels over the surface of the ground to reach a stream channel and through the channel to the basin outlet. This process occurs relatively quickly. And the subsurface runoff, the portion of runoff travels under the ground to reach a stream channel and to the basin outlet. It includes the interflow and the groundwater runoff. So interflow is the portion of subsurface runoff that travels laterally through the unsaturated zone or through a shallow perched saturated zone towards a stream channel. That process is slower than surface runoff. And next is the groundwater runoff, the portion of subsurface runoff that comes from the infiltration and subsequently percolation down to the water table and eventually reaches to the stream channel. This process occurs relatively slowly. So here you can see this is the precipitation. So some part of precipitation is again evaporated. Then some part is interception and going for the depreciation storage. Again from that evaporation takes place. Some part of it goes in the ground by infiltration and remaining part is moving towards this the stream by overland flow. So this is the infiltration. Again it goes into the unsaturated zone storage. Then interflow takes place and again it goes into the stream flow. Again in some part obviously that evapotranspiration is there. Then in this thing some part is go in the percolation, that is to the groundwater, that is again in the saturated zone storage. So by base flow it again goes to the stream flow and again evaporation takes place from the stream flow and again this cycle continues. So you can see here direct runoff and subsurface runoff in this portion. Now what are the factors affecting the runoff? First is the climatic factor, that is type of precipitation, intensity of rainfall, duration of rainfall, area distribution of rainfall, then antecedents or previous precipitation, then other climatic factors that affect that evaporation and transpiration. So these are the factors affecting the runoff by uh, this climate. Actually, in type of precipitation, how much water is falling on the earth, that is important. Then if the intensity high, obviously the runoff is again high, and the duration is more, then runoff will be more. Then area distribution of runoff, so how this water is accumulated or collected at the outlet of the catchment area, again that is also important. If the rainfall intensity high at one point and low at another point, again that affects on the runoff. Then if the previous runoff is there or a previous precipitation is there, obviously there will be a more runoff because of the previous precipitation. The soil is saturated or percolated, water has been percolated in the ground, so that rate is minimum. And other factors like evaporation and transpiration, uh, because of which what is the rate of all these things, it is if sun's intensity is more, then obviously evaporation is more. So all these things affecting on the runoff. Then next is the physiological factor, that is land use, type of soil. So land use, if the urban land is there, obviously the runoff will be more, or if the paved area is there, the runoff will be more, no percolation in ground will be there. And type of soil, if the soil is permeable, then obviously runoff will be more. Then area of the basin or the catchment, if it is more, then runoff is obviously more. Shape of the basin, that again plays important role in the runoff. Then elevation, slope, orientation, type of the drainage network, indirect drainage or artificial drainage, all these factors affecting the runoff. Now, estimation of the runoff. So, there is a empirical formula to find the peak runoff, that is Dickens formula, Ravi's formula, Iglis formula, and Kosla's formula. Then rational method is there, and unit hydrograph method is there. So in Dickens formula, we have, it is developed in 1965, and it states that QP equals to CD into A raised to 3 by 4, where QP is the peak discharge rate, CD is the constant, that is Dickens constant, ranging from 6 to 30, and A is the drainage basin area. So for the Indian conditions, the different values of CD has been given over here. In northern states, that is plain and hills, it is 6 to 11 to 14. In central states, it is 14.28, and in coastal area it is 22.28. Then the Ravi's formula. So it is developed in the 1884. It states that QP equals to CR into A raised to 2 by 3. So QP is the peak discharge rate, A is the drainage basin area, and CR is the constant. The Ravi's constant. So uh, a table has been given over here for this constant, that within 18 kilometer from the east coast, that is 6.8, 80 to 160 kilometer from east coast, that is 8.5, and for hills it is 10.2. So obviously all these formulas has been developed by the person who are working in the this British Raj, and to calculate the rainfall in this Indian conditions, they have developed different formulas for their regions. Now the English formula. It is developed for the areas in the old Bombay state. It states that QP equals to 123A divided by under root A plus 10.4, where QP is the peak discharge and A is the area of catchment in square kilometer. And the Kosla's formula. In this method, the amount of mean annual runoff is calculated by following formula, that is R equals to P minus T divided by 3.74, where R is the mean annual runoff of watershed by centimeter, then P is the mean annual precipitation by centimeter, and T is the mean annual temperature of in degrees Celsius. So all this formula has been developed to calculate the runoff conditions in India. Now the rational formula. So this method was originally developed for urban catchments. Thus the basic assumption for development of this method were made for urban catchment. However, this method is fairly applicable for small agricultural watershed of 40 to 80 hectares size. The rational method takes into account the following hydrological characteristics or processes, that is rainfall intensity, rainfall duration, rainfall frequency, watershed area, hydrologic abstraction, and runoff concentrations. So assumptions are made for this method are, the rational method is based on the assumptions that constant intensity of rainfall is uniformly spread over an area. The effective rainfalling on the most remote part of the basin takes a certain period of time, known as a time of concentration. To arrive at a basin outlet, if the input rate of excess rainfall on the basin continues for a period of a time of concentration, then the part of excess rainfall filled in the most remote part of the basin will just begin its outflow at the basin outlet, and with it the runoff will reach its ultimate and maximum rate. Now consider a drainage basin which has a rainfall of uniform intensity and of longer duration. On plotting the relationship between the cumulative runoff rate Q and the time, the rate of runoff shows the gradual increase from the 0 to a constant value. As you can see over here, the runoff increases with the increase in flow from the remote areas of the basin to its outlet. If the rainfall continues beyond the time of concentration, then there is no further increase in the runoff and it will remain constant to its peak value, as you can see over here. And at the end of rainfall, again this that outflow is going to decrease. That is runoff rate going to decrease. So peak runoff, that is QP equals to 0.278 CIA, where QP is peak discharge, C is coefficient of runoff, A is the area of the catchment, and I is the mean intensity of precipitation, that is mm per hour, which is equals to maximum rainfall divided by the time of concentration. So the time of concentration is again 0.01947 L raised to 0.77 and S raised to minus 0.385, where L is the maximum length of the travel of the water in meters. So here you can see the different coefficient factors for the different soil conditions in India. Now, what are the abstractions from the rainfall? So the hydrological abstractions. So hydrological abstractions, that is interception loss due to surface vegetation and building. Interception loss is high in the beginning of the storms and gradually decreases. Then the evaporation, that is from the water surface, that is reservoir, lake, ponds, river channels, etc., and from the soil surface appreciably when the ground water table is very near to the soil surface. Then transpiration from the plant leaves. Transpiration is the transfer of the soil moisture from the soil to the atmosphere by the action of vegetation. Plants transfer the water vapor through their foliage. Then evapotranspiration, the combined process in which water is transferred to the atmosphere from the open water surface and the vegetation. Then the infiltration, which takes place as a part of rain percolates through the soil. It is usually the largest abstraction and therefore the most significant effect on the runoff. Infiltration rate generally decreases with the time the rainfall proceeds, the soil becomes saturated. Then the surface detention. Water temporarily detained on the surface, controlling factors of the surface, that is micro relief, vegetation, surface slope, topography, rainfall, etc. And the surface retention. Water retained on the ground in the micro depressions. These water either evaporate or infiltrate into the soil. Nature of depreciation as well as the size is largely function of the original land form and the local land use practices and the erosion patterns. So here you can see this graph shows the rainfall, that is this, and uh, how this abstraction took place. So you can see this is initially this depreciation, storage and interception is high when the rain starts falling in period 1. So initially this rate is quite high because the storage has been depressed, less storage is there, and to fill this depression this rate is high. Later on you can see this infiltration rate goes on decreasing. This part after this fully saturation or the filling the depressions, this infiltration takes place and it goes on decreasing as the rainfall continues, and the remaining rainfall is nothing but the this excess rainfall, and continuously this evaporation is also taking place. So again you can see over here this initially this evaporation rate is high, but as time passes this evaporation is at the continuous rate. So this is nothing but the abstractions of the runoff. This shows it in this graph over here. Now, what are the factors affecting to the evaporation? First is the temperature. Warmer the evaporating surface, higher the rate of evaporation. Then relative humidity. Drier air evaporates more water than the moist air. The wind speed. When the wind is light, the evaporation is slow. Area of the evaporating surface. Larger area of the evaporating surface increase the rate of evaporation. Air pressure. Lower air pressure on the open surface of the liquid results in the higher rate of evaporation. The composition of water. The rate of evaporation is always greater over the fresh water than the salt water. What are the methods of measurement of evaporation? So, in direct methods, that is water budget technique, then lessimeter is there, that is weighing type, non-weighing type. In indirect methods, aerodynamic method or mass transfer method, energy budget method is there. Then Penman's equation is there. Blainian cradle method is there. Jensen Hayes method is there. Hargrove method or pan evaporation method is there. Then the transpiration. It is the process by which the water vapor escapes from the living plant leaves and enter into the atmosphere. Evapotranspiration. It is the combined process by which water is transferred to the atmosphere from open water and the vegetation. Again, what are the factors affecting the evapotranspiration? The climatological factors like percentage sunshine hours, wind speed, mean monthly temperature, and humidity. The crop factors like type of crops and the percentage of growing season and the moisture levels of soil. These are the factors affecting to evapotranspiration. Then the estimation of evapotranspiration, that is by lessimeter, class E pan method, Penman's method, Harger method, and Blainian cradle method. Infiltration is the process of water entry into the soil from rainfall or irrigation. Percolation is the process of water flow from the one point to the another point within the soil. Infiltration rate is the rate of at which the water actually infiltrates through the soil during a storm and must be equal to the infiltration capacities or the rainfall rate, whichever is lesser. Infiltration capacity is the maximum rate at which the soil in any given condition is capable of absorbing the water. Now the measurement of infiltration. The rate of infiltration is initially very high. It goes on reducing with the time, and after some time it becomes steady. The rate of infiltration for a soil is measured in the field and as well as in the laboratory. These are known as infiltrometers. What are the types of infiltrometers? The flooding type infiltrometer, that is single tube flooding infiltrometer, and double tube flooding infiltrometer. And there is a sprinkling type infiltrometer or rain simulators. In that, needle drip systems, standpipes, sprinkler nozzles, and rotating booms are there. These are the infiltration of various soil types. That is, for sand it is very high, and for the light clay it is low. So you can see the infiltration indices. The average value of infiltration index is called as the infiltration index. The types are phi index and W index. So here you can see these are the graphs showing this W index and phi index. So for W index, we have the formula, that is P minus R minus IA divided by T. And for phi index, we have the formula P minus R divided by T. So what is P? P is the total storm precipitation, R is the total surface runoff, I is the initial losses, and T is the time elapsed or elapsed time period. So here you can see both the graphs has been drawn, that is these are the infiltration indices. So the W index is more accurate than the phi index because it subtract the initial losses, as here you can see the initial losses taken into the consideration, and here it is not taken into the consideration. So here you can see infiltration capacity curve. This is the phi line over here, and these are the hydrographs. These are nothing but the hydrographs, and this curve has been shown over here. Now factor affecting the infiltration. The condition of land surface, that is cracked, crusted or the compacted. Then land vegetation cover is there. The surface soil characteristics, that is grain size and gradation is there. Storm characteristics, that is intensity, duration and magnitude of the storm. And surface soil and water temperature, chemical properties of the water and soil. These are the factors affecting to the infiltration. So this is all for today's lecture. Thank you.